right, so section 12.3 is on what we call conditional probability. So these are going to be ones where it's like, find the probability that someone has a brother given that they have a sister. So you're going to be given something already. Okay, so like I said, we're going to do this with a Venn diagram to begin with. Okay, so we're going to create a Venn diagram with the number of people in the class that have brothers, sisters, or both. Okay, so we're going to go through it really, really quick. Okay, so when I go around, you're just going to tell me if you have a brother, sister, or both. Okay, so Christian, how about you? Both. All right, Evan? All right, Michaela? Brother? I didn't hear you.
Both.
Both. Okay.
Both.
Quickly. Sister?
None.
None.
Both.
None.
Both. None. Sister. 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 Brother. Brother.
Okay, so we have 1, 2, 3, 4, 5, 6 that have a sister. We have 3 that have a brother. We have 1, 2, 3, 4, 5, 6 that have both, and we have 1, 2, 3, 4 that have none. Okay, so if we were filling in a Venn diagram, we always start in the middle. So we have 6 people that have both a sister and a brother. We had 3 people that had brothers only. We had 6 people that had sisters only, and we had 4 people that were only children. Okay, so our questions say, it says the probability that a student has a brother given that he or she has a sister. So whenever we say given, we just draw a straight vertical line, and that is read, oops, I did G, given that they have a sister. So this represents given. So brother, given, sister. So what this means is that we are told that they have a sister. So if we know that someone has a sister, then we're automatically in this circle right here. So we only have 12 people in the class that have a sister. Okay, so then what's the probability that they have a brother? How many people have a brother out of that set? 6 out of the 12, right? Does that make sense? So we're going to have 6 people have brothers and sisters over the number that has just a sister, which is 12. So this probability would end up being 1/2. Does that make sense? So you're zooming in on one particular area. So this says find the probability that a student has a brother if you're given that he or she does not have a sister. Okay, so now we're saying we don't have a sister. So that means that this area is out. We can't be there. So we're only in this region. Okay, so how many people are in that region? 7. So of those 7 people, how many have a brother?
7. What?
Good.
Brother and.
Okay, so we're saying he or she does not have a sister. So there are only these people that do not have sisters. How many of them do not have a do have a brother? I mean, 3. There's 3 out of the 7 that do have a brother. Okay, so you were saying given that they do not have a sister, so there's only 7 people. How many of those people have a brother? So 3 out of 7. And the next one, so it says the probability that a student has a sister if you're given that he or she has a brother. And this does not end up being the same as brother given sister. Okay, so if we're given that someone has a brother, how many people total have a brother? 9. So how many of them have a sister? 6. So we have 6 out of 9, which is 2/3.
Why do you put 6 on?
Because you're saying given that they have a brother, so that's this part right here. This is the number of people that have a brother. How many of them in that set of this 9 have a sister? Okay, so these 6. Okay, next step. Okay, so we don't always have to draw out a Venn diagram for these. It is helpful, so if you guys are very visual people, you can do that on your homework. You can draw little Venn diagrams. But there is a formula that does this as well. So it says we've talked about dependent events before. So in one example, we talked about having a raffle and not putting names back in the box. Okay, so I have 2 friends, Trent and Brian, that I went to grad school with. They were interested in probability. That's what they studied. So they're in this problem. So it says find the probability that Trent wins the first prize and Brian wins the second prize in this raffle. So what you're really doing is you're saying you're finding the probability that Trent wins that first thing, and you're multiplying by the probability that Brian wins the second thing, but it's not the same as Brian's probability at the very beginning, right? What you're doing is you're finding the probability that Brian wins given that Trent has already won that first prize. It's different, right? It's different than just the probability that Brian wins at the very beginning because you've taken that name out. So that's what we've been doing this whole time when we do those trees. We've been doing conditional probabilities. So it says, suppose we want to find the probability that events A and B occur. If you want the probability that A and B both occur, you have to do the probability that A happens and then multiply by the probability of B given A. Okay, remember when we talked about independent events, we could just say the probability that A and B happened was the probability of A times the probability of B. But now that we're talking about dependent events, we need to say given that A has already occurred. Okay, so it's a little bit different. So it says, well, what if you want to solve for the probability of B given A? Well, then the probability of B given A is going to be the probability of A and B happening divided by the probability of A happening. You just take this part and you divide it over. Okay? So you might see this written a little bit differently if you look at any probability books. Instead of writing out A and B, this is often written as P, the probability of A intersect B. That word means and. It's read intersect, but it means and over the probability of A. So you might see that as well. Okay, so if you see a funny symbol in your homework, that's what that means. It means and. Think about what it means with a Venn diagram. Intersect, it means where the two circles intersect, right? That's the probability of B and S. B and S is in the middle. Does that make sense? Having a brother and a sister is what's in the middle. All right. A intersect B, which is the same as A and B. Okay, so the first one's a little confusing the way I wrote it, so let me kind of explain. So it says, Mrs. Cox gave her class 2 tests. 25% of the class got an A on both tests. 42% of the class got an A on the first test. What percent of those who got an A on the first test also got an A on the second test? This is your given part. You were told that they got an A on the first test. Okay, so we've already eliminated part of the possibilities because we're saying, oh, they definitely got an A on the first test. Now what's the probability that they got an A on the second test? Christian, you with me? So we're doing the probability of A on the second test given that they got an A on the first test. So we were given that they got an A on the first test. What's now the probability that they got an A on the second? So it works out to be the probability that they got an A on the second and they got an A on the first. And then you're dividing by the probability that they got an A on the first. Yes?
Is it saying that 25% of the class got an A on both tests, the same as asking what percent got an A on the first and the second?
Yeah, so I often get that question. So saying 25% of the class got an A on both tests, that is not the same as saying the probability that saying the probability that someone got an A on the second test given that they got an A on the first. Because what happens is, it's like with the Venn diagram, you're zooming in to only the people that got an A on the first test. So we're saying we're now in this set. If they got an A on the first test, right, they're probably going to be more likely to get an A on the second test as well. So the probability that they get an A on both tests, right, is a little bit different. Saying that they got an A on both tests, I mean, I'm taking the whole class, right? I'm taking the whole class and I'm saying, what's the probability that they get an A on both tests? It's going to be, you know, maybe not so good. But if I say, oh, Catherine, you got an A on the first test, well, her probability of getting an A on the second test is probably a little bit higher than the rest of the class. Does that make sense? Like, if people usually get, like, they get an A on one, they might get an A on the other. Does that make sense? But if you're taking the whole class, it's different. Okay, so the probability of an A on the second and an A on the first, that was the 25%. That's an A on both tests. And then 42% of the class got an A on the first. So when you divide those out, 0.25 divided by 0.42, you end up getting 25 out of 42, which you can find the decimal if you want, but I kind of like having the fraction. Okay, if I find the decimal, I don't know what 25 divided by 42 is. Can I find it? So it's 0.595. So that's a little bit more than getting an A on both tests, right? It's a little bit different. Okay. All right, so the next step. So it says the probability that it is Friday and a student is absent is 0.03. Since there are 5 school days in a week, the probability that it is Friday is 0.2. What is the probability that a student is absent given that today is Friday? So if I tell you it's Friday, it's probably more likely that people are going to be absent. Okay, so we're saying given that it's Friday, what's the probability that someone's absent? So it works out to be the probability that they're absent and it's Friday divided by the probability that it's Friday. So absent and Friday is 0.03. The probability that it's Friday is 0.2, so I'll write it as 0.20. So if you move your decimal place over twice on both of them, you end up getting 3 over 20. Right, so if you do 3 divided by 20, right, it's the same as 15 divided by 100, so it's 0.15. Okay. All right, next up. How many of you guys get an allowance? How many of you guys get an allowance? You just ask your parents for money when you need it, but you get like a weekly. Yeah. Bi-monthly. Oh, fancy. Yeah, so how many of you guys do chores for? You do chores, but you don't get an allowance?
I don't do anything.
You don't do anything? Your poor mom.
Well, my mom, like, she yelled at me.
You don't do like what my husband does and like try something but do it wrong, and then I'm like, oh, you're never going to do this
I have
again.
to, like, I would pick up the trash, but I won't take it all into the trash. I like to do that anyway.
I see. All right, here we go. So in the United States, 56% of all children get an allowance, and 41% of all children get an allowance and do chores. Shh, guys. What is the probability that a child does household chores given that the child gets an allowance? So we set it up. We know it's a conditional one. So we're saying chores, probability of chores, given that they get an allowance. Okay, and if you think about it, it kind of makes sense. If you know that someone gets an allowance, they're probably doing something to earn that allowance, right? They're probably doing chores. So they're probably more likely to do chores. Okay, so it's going to be the probability of chores and allowance divided by the probability of doing of getting an allowance. So the probability of chores and allowance is 0.41. The probability of allowance is 0.56. So when you divide it out, you get 41 or 41 over 56. Or if you did the decimal, it's 0.732.
And you're okay with us leaving it?
Yeah, I like the fraction form too. All right, so what a lot of people do when they do the homework is they just say, oh, I get it. It's just going to be like the smaller percentage divided by the bigger percentage. And while that has worked for the first few problems, it does not always work because sometimes I like to mix it up. And this next one's an example of mixing it up. So it says at UHS, 32% of students play soccer. So let's kind of write what we have. We have the probability of someone playing soccer is 0.32. The probability that a student plays basketball given that they play soccer. So basketball given soccer is 0.5625. So you see how this one's different? I gave you the given part. Basketball given soccer. We need to find the probability that they play basketball and soccer. So that's the one we don't know. So a conditional probability, I'm going to do the probability of basketball given soccer is going to be the probability of basketball and soccer divided by what? Probability of soccer, right? What I was telling you is that second number, or the second letter, is always what goes on the bottom. If you say basketball given soccer, you have soccer on the bottom. Okay, so we have basketball, probability of basketball given soccer is 0.5625. We don't know the probability of basketball and soccer. You could write that as just X if you want, or you can write it out. Divided by 0.32. So if I want the probability of basketball and soccer, I just multiply that 0.32 over. So 0.5625 times 0.32. So I get 0.18. So what does this mean in the problem? That means that 18% of the students play both basketball and soccer. Okay? Is this making sense? So let's kind of go back to where we were talking about the Venns. Yeah.
I'm kind of confused. What's the difference between the probability that they're not play basketball given they play soccer and basketball?
Okay, so that's what I was talking about. So if someone plays soccer for the school, then they're probably more likely that they play another sport. Would you agree? Like if they play one sport, they might probably play more than one sport. Okay, so if I'm taking the entire population of the school, the probability that they play basketball and soccer, I don't know what that is. I can find it, okay? But if I want to talk about this person plays soccer, what's the probability that they also play basketball? It's actually an increased probability. Like you're saying, I'm taking from a smaller set. The people that play soccer are most likely athletic, right? They want to do sports, they have time for sports, so they are more likely to play basketball as well. So it's a little bit different. If you take a smaller set, you're saying, oh, they definitely play soccer, then now your probability is probably increased, okay? All right, so number 5. So it says the data from a survey of 140 students shows that 37 study music, 103 play a sport, and 25 do neither. Create a Venn diagram to illustrate the data collected and then determine the probability that if a student is selected at random, they study music given they play a sport, and so on. So we're going to do a Venn. And for one of these questions, we definitely, we don't need a Venn. And I'll show you what I mean by that. So we're doing music and sports. Okay, in order to solve a Venn diagram problem, the most important part of the Venn diagram is right here in the middle. Okay, if you can get the number in the middle, you will be able to solve the Venn diagram very quickly. Okay, but in this case, we don't have that number. It says a certain number study music, a certain number play a sport, 25 do neither. It doesn't say how many do both. Okay, so what we need to do then is we make that X in the middle. Okay, so I say, well, X are going to do both, study music and play sports, right? And if I know that 37 study music, that means that I have 37 minus X in the music-only portion. Because if I had like 5 doing both, then that means that there would be 32 studying only music. Okay, and then this one's going to be 103 minus X because 103 played a sport. But we have to account for the number that did both. And 25 do neither, so we have 25 out here. So I can now create an equation because I know there's a total of 140 students. So I can say, oh, 37 minus X plus 103 minus X plus 25 equals 140. And you can solve. So your minus X plus X goes away. I have 140 minus X plus 25 equals 140. So 165 minus X equals 140. So X is 25. So what I just found is the number that do both, right? So I have 25 in the middle. Then what's in this portion right here? What number do I put in that circle? I put 12, right? Because it's 37 minus 25. And then in this area, if I subtract out 25, I'm going to have 78. Okay, so those are my different numbers in the Venn. Does that make sense how I got that? Some people say, oh, well, I just add up 37 and 103 and then I subtract 25, and that actually like you can do that as well. You're just thinking about the double counting, like you're saying how many did I double count. That's why you're subtracting 25, because you've counted them twice in both sets. Does that kind of make sense? You can do that as well, but usually have students write out the equation so they know where things are coming from. All right, so what's the probability that they will study music? So the probability that they study music would be there's a total of 37 out of 140. I didn't need a Venn for that. I just took the total number that studied music out of 140. Okay. That would be music only. Like if I said, what's the probability that they only study music? Okay, but that would be this studying music in general. Like they could also do a sport and study music. All right, what is the probability that they study music given that they play a sport? Okay, this is where it gets a little bit harder. So you are given that they play a sport. That means that you're zooming in to this part of your Venn. You're saying, oh, I'm only going to look at this circle here. I'm given that they play a sport. How many people play a sport? 103, right? What's the probability? So of that 103, how many of them also study music? 25. Does that make sense? So you're doing 25 out of 103. Okay, if you did the formula, it would be fine. It would work out. You would have the probability that they study music and do a sport divided by the probability that they do a sport. And it's just a little bit longer because these are probabilities, right? They're fractions. So the probability that they study music and play a sport would be 25 out of the total of 140. Oops, 140. And the probability that they play a sport was 103 out of 140. And you know when you divide fractions, you flip the second fraction and multiply. So you see how you end up getting the same thing. You get 25 out of 103. But I always say, if you have the Venn, use the Venn. Like, you don't want to do this long formula when you can just say, oh, I'm going to zoom in on the sports people, right? Now, looking only at the sports, how many of them do music? Do you see how it works both ways? You can do either way. All right, so the next one, they will play a sport given that they study music. So the probability of sport given music, it's not going to be like the opposite of this one or anything, of the last one. So we're going to say zoom in on the music part. So we're zooming in here. How many people play music? 37, right? How many of those people that play music also play sports? 25. So this is going to be 25 out of 37. Do you understand how I got that? Okay. All right, so next up. This is a big Venn. Oh man, this is like, do you know your stuff or not? I don't know if I gave you much room to draw the Venn. You might want to kind of draw it on the right side where there's a little bit of room. Make it a little tiny. Like you could probably draw it like over here, I was saying. I have space down here at the bottom, but if I was squeezing it in here, I could do it. It would look like this. It's 3 circles.
It looks like the hazardous waste.
It does look like hazardous waste, yes. So it says in a class of 360 seniors, 125 study Spanish, 95 study chemistry, 165 study math, 18 study Spanish and chemistry, 75 chemistry and math, 20 math and Spanish, and 15 study all 3. Ooh, man, this is a lot of data. All right, so this is why it's a 3-circle Venn. Do you see how I overlapped it so I can see the very center? Make sure that you can see the very center. Did you have trouble drawing it? Yeah. So we have Spanish, chemistry, and math. We're going to fill in some different numbers. The key to doing a Venn is to always start in the middle. If we can find that number in the middle, then we're good. Do we have this number in the middle? We do. We said 15 study all 3 subjects. So we have 15 right in the middle. All right, now we're going to work our way backwards. So now I'm going to do 20 study math and Spanish. Well, math and Spanish is going to be this little like football shape right there. Do you see where those 2 circles, math and Spanish, are overlapping? We need a total of 20 in there. How many do I have already? I have 15. What do I need? 5. So I'm going to put 5 right there.
20.
Because I need a total of 20 studying both math and Spanish. All right, and then the next one, so 75, study chemistry and math. So I look at my chemistry and math, where they overlap. It's right here, another little football shape. I already have 15 that study all 3. So if I want a total of 75 studying chemistry and math, how many do I need in that other little portion? I need 60, right? So there's 60 in there. And the next one, it says 18 study Spanish and chemistry. So Spanish and chemistry overlap right here. I want a total of 18. I already have 15 there. What do I need? 3. So I continue to work my way out. So the next one, it says 165 study math. Well, in math, I have 5, 15, and 60 so far. See how I'm looking at this like whole thing right there? So I have 5, 15, and 60. That's going to make 80. So how many more do I need in the math? 85. Do you see it? I need a total of 165. I had 80 already in these 3 pieces right here. So I needed 85 more. All right, 95 study chemistry. So if I look in my chemistry circle, I already have 3, 15, and 60. That's going to be, let's see, 78. So I need to do 95 minus 78. So I get 17 in here. And then the last little bit, I have 3, 15, and 5 already in the Spanish. That's making a total of 23. I want a total of 125. So I need 102 in Spanish only. Are you seeing how it works? Okay, that's the hardest part. Once you have the Venn, then use the Venn. Right? You don't have to use all the crazy formulas that I taught you at the very beginning of this chapter. You can, but you don't have to. So if I say the probability of only doing Spanish So just Spanish. That means that I am in this portion right here, right? 102. So I have 102 students out of the total of 360. And you can let your calculator reduce that for you, 102. I know they're both divisible by 3 at least. So when I do math 1, I change it to a fraction, I get 17 out of 60. So they were both divisible by 6. All right, the next one. So the probability of studying math and chemistry but no Spanish. So let's look for it. Math and chemistry would overlap in the football shape right there. But we did not want Spanish, so we don't want that center. So we only want this portion right there, 60. Do you guys see it? Kind of hard to see. So it's 60 out of the total of 360. So when I reduce, I get 1/6. Okay, none of these subjects. So we didn't find one part of our Venn. I guess I didn't finish the Venn, did I? I need the part that's in none of those circles. So the part that's out here. Did anybody find that? It is 73, yeah. So you're going to add up all those amounts. The easiest thing to do is, you know, math is already, let's see, math was 165, so then do 165 plus 102 plus 3 plus 17, like the portions that were not inside that circle. And you end up getting 165 plus 102 plus 3 plus 17. You end up getting 287, and then subtract that from 360, you get 73. Okay, so none of these subjects is going to be 73 students out of the 360, which I don't believe reduces. All right, now we'll do the given one. So it says the probability that you study Spanish given that he or she studies math. So you can do the formula. You could say the probability of Spanish and math. I'll do intersect all over probability of math. You can do that. You would get it. So if I did that, so don't do this, but kind of pay attention with me. If I said Spanish and math, I'd be like, okay, Spanish and math, that's right here. That was 20 of the students out of the total of 360. And then just math was a total of 165 out of 360. So when you divide those out, you get 20 over 165, which reduces. So you could do that. But if you have the Venn, use the Venn. Okay, and there's a couple on your homework where you draw the Venn diagram, so use it. So what you're saying is that you were given that they study math. So we're zooming in the math circle. We're looking only at that circle. Everything else we're totally ignoring. It's like it's gone. What is the probability that they study Spanish? Well, how many of those 165 study Spanish then? 20 out of 165. Does that make sense? 20 out of 165. So you're only in the math circle, which is 165 students. You want to find the number that studies Spanish in that circle. There's only 20. So 20 out of 165.
But then you're also in the chemistry circle.
That's okay. I didn't say anything about chemistry.
Okay.
So it's 4 over 33. They're both divisible by 5. Okay, so try the next two. So do math given he or she studies chemistry, and do Spanish given he or she studies chemistry. Give me a second to do it. Yeah, hang on. All right, so if you're saying math given he or she studies chemistry, then you're saying, okay, I'm going to zoom in on the chemistry area. We knew that there were a total of 95 that studied chemistry. So of those 95 people, how many study math?
75.
75. So your answer is going to be 75 over 95, which reduces to 15 over 19. All right, and then the next one's probability of Spanish given that they study chemistry. Well, that means you're given that they study chemistry. You're already in that circle. So how many total people are in chemistry? 95. How many of those study Spanish? 18. So your answer is 18 out of 95. Did you guys get those? Yeah. Okay. So use the Venn if you have the Venn. That's usually the best way.